So this is going to be a video based off of your second law calculation. You can see the problem in front of you. A truck carrying the world's largest watermelon has a mass of 11,870 kilograms and accelerates at a rate of 0.51 meters per second. In this problem, we are going to ignore friction and we are trying to determine the net force exerted by the truck. Well, in order to do second law problems, there's always like a method to it of, let's first write them out. Number one is you always want to draw a free body diagram for it. So just be careful when doing this because that is by far the number one mistake that students make. That afterwards, number two, you are going to solve for the net force of the object. Then you are actually going to write your own equation, which is really, really nice because now it's not just plug and chug. And finally, for 4, you get to solve. What ends up happening is that largely you have to follow these steps because it's not just a normal type of problem anymore. So with your problem, let's start out with a free body diagram. And I will change the color to, let's say, purple. What ends up happening is that the free body diagram for this truck, you have a force of gravity going downwards, you have a force normal going upwards, and then finally you have an applied force, and in this problem your applied force is going to the left, so force applied. Now, normally you would have friction off to the right, but in this problem we are going to ignore friction, so therefore this is your free body diagram, and since it is not accelerating upwards or downwards, your force normal and your force of gravity are going to be equal. So, free body diagram, done, check. Now let's solve for the net force. So in order to solve for net force, remember that net force is just the addition of all the forces. So I can say force normal plus force of gravity plus force applied. Now, the problem with this, though, is that this equation right now of net force is not correct. And the reason for this is that if you think of like an XY coordinate system, basically there's always positives and there are negatives. So I follow the exact same rules of upwards I call positive, to the right I call positive, downwards I call negative, and to the left I will call negative. So in this problem, your force of gravity is actually negative and your force applied is negative, while your normal force is the only one that is positive. So let's rewrite our net force equation using those boundaries. So net force is equal to the positive force normal minus force of gravity minus force applied. This is where you start out. Now, the secret here and what makes it rather simple is that you can see force of gravity and force normal here are equal, meaning that they actually cancel out here and you get that your net force is equal to a negative force applied. Okay, done. You have solved for your net force. Now let's try and figure out how to solve for our own equation. Well, our own equation is actually really, really simple. And this is where Newton's second law comes in. Net force is equal to the mass multiplied by the acceleration of the object. But here we have solved that the net force is equal to the negative force applied. So I write net force is equal to negative force applied. And I have a very, very simple substitution. Negative force applied is equal to mass multiplied by acceleration. Okay. Now notice, this is not your original. This is not what you solve for net force. It's not Newton's second law. This is your own equation, and this is what you are going to use for the remainder of the problem. So own equation, check. And finally, we want to solve. I haven't used red yet. Deal. So to solve, it's the exact same problem of what ends up happening. Rewrite your equation, and we are going to go through the knowns and unknowns. Force applied is equal to, in this problem, our unknown. We're trying to figure out the force. The mass of this object is 11,870 kilograms. And the acceleration of this object is 0.51 meters per second squared. Now, once again, we do not need to rearrange. It is already set up for our problem. So all we have to do is we have to plug it in. Negative force applied is equal to the mass, 11,870 kilograms, multiplied by 0.51 meters per second squared. And you are good. Then plug it into your calculator. You should get that the negative force applied is equal to, and your calculator answer is going to be 605.3.7 newtons, but we want 2 sig figs from the 0.51. So our final answer is going to be that negative force applied is equal to 6,100 newtons. Now, the only thing left is that you don't want a negative force applied. The force applied itself is not negative. The value of the forces are negative. So I'm going to switch it. I'm going to say that force applied is equal to negative 6,100 newtons. And there's one more issue. Negative can be one of two things. Negative is either going to be going downwards on our problem, or it is going to be going to the left on our problem. We needed to know whether it is a downwards negative or if it is a leftwards negative. And the way we do that is we either use an X or a Y at the end. So I'm going to write that the force applied of this object is equal to negative 6,100 newtons in the X direction. We use X hat. So that finally is the very, very end of your problem.